Hey there, welcome to day 10 of 100 Days of Code. And today we're going to learn about functions with outputs. Previously, we've already seen the other two flavors of functions, a plain function and also functions with inputs. But in today's lessons, we're going to be using the skills that we've learned, and we're going to be extending our knowledge of functions to build a calculator app. I think at some point in every programmer's lives, they will have built a calculator app. So if that hasn't already happened to you, then today is your lucky day because that's exactly what we're going to be making. So it's a simple text-based calculator, and we can start off by writing a number and then picking one of the operations: plus, minus, multiply, or divide. So I'm going to divide this by 2, and then it shows us the full calculation: 5 divided by 2 equals 2.5. And now we can continue calculating with the answer from the previous step, or we can type n to start a new calculation. Let me type y, and maybe I'll do 2.5 plus 6, and now I get 8.5. By the end of the lessons today, you'll have understood how functions really work, how you can use them to reduce redundant code, and how you can provide inputs to functions as well as providing outputs. Once you're ready, head over to the next lesson and let's get started. To begin, the first thing I want to talk about is more on functions. So we've already seen a couple of things that we can do with functions. The first thing I showed you was how to create a very simple bog standard function using the def, the name, the empty parentheses, and then the colon. And then within the body of the function, you can do a bunch of things which will be carried out every single time you trigger or call the function, like this. And the first type of function basically just helps you reduce the amount of code you have to write when you have instructions that you want to execute repeatedly. Now, the next type of function we saw actually had something inside the parentheses. And this something is an input which can be passed over when we call the function. So in this case, 1, 2, 3 is the argument which gets passed in to this parameter called something, and then it gets used within the body of the function. The second type of function, the functions which allow for inputs, gives us the ability to modify the code in the function and to get it to do something different each time depending on what input was passed in. We're now on to the final sort of flavor of functions, and these are functions which allow you to have an output once the function is completed. We start off with a simple function, and in this case you'll notice that even though I'm actually not giving it any inputs. The inputs and the outputs are completely separate from each other. So this is a normal function that you've seen many times now. And within the body of the function, I'm going to do some piece of calculation. Let's say I'm going to calculate what is 3 times 2, and then save it to a variable called result. Now, once that's done, I can use the output keyword, which is return, and then after that keyword, I can put whatever it is I want to be the output of this function. So in this case, the output is the result. And what that means is when I call this function later on and it runs, then it will go ahead and output this result, and it replaces this line of code where this function was called. Now, that result is held in the code where the function was called, and I could save it to another variable. Result, of course, equals 3 times 2, and that means this output now equals 6. So this is what the code might look like. Somewhere I would define my function which has an output, which you can tell by the return keyword. Now, at some other point in my code, I decide to call that function. And once that function executes, that return, or whatever is outputted, replaces the function call. And at the very end, it means this variable output will store whatever the output is. So in this case, output would be equal to 6. The way that I like to think about functions with outputs is almost kind of like a machine, right? If you had a machine where in goes some empty bottles, and after some processing or some inputs, out comes a bottle filled with milk. So in this case, this function has an input, the empty glass bottle. It has an output, the glass bottle filled with milk. And in the middle, there's some processes or some code that's being executed to create this change. This ties together all the things that we've learned about functions. So now head over to the Day-10 starting replit and go ahead and fork your own copy of it. Now, once you have your own copy of it, we're going to create some functions with outputs of our own. But let's start off by creating a new function, which I'm going to call format name. And the reason is because this function is going to take a first name and a last name, and it's going to change those inputs. Even if it was lowercase or if it was all caps, it's going to change it into title case. Something like this, where the first letter is capitalized in each word. To begin, I want you to create this function and then go ahead and add two inputs to it. One called fname, so first name, and another called lname, which is the last name. Pause the video and give that a go. Alright, so all we have to do to add inputs to our function is just to put the names of these parameters inside the parentheses. So now our function is able to take these parameters as inputs whenever this function gets called. The next step is we're going to convert these strings that gets passed in. So it could be something like this, all lowercase, it could be all capitalized, or it could be kind of random, right? Like some are capitalized, some are not, but we're going to make it all uniform. So all of these are going to end up like this. And to do this, we can search around in Google and you might come across a similar question in Stack Overflow. How do you convert a string to title case in Python? They have an example and it's trying to do exactly what we're trying to do. If we take a look at the answers, you can see that somebody is helpfully pointing to this title function. So you take a string and then you write .title, and then afterwards the string gets transformed and every word now starts off with a capital letter. And if you want to know more about how this title case works, then you can click on that link in title and then have a read through the Python documentation. Once you've read through that, go ahead and modify this fname and lname so that they end up being both in title case. Pause the video and give that a go. Alright, so we want to go ahead and take this fname and then write a dot and then write title to convert it to title case. Once we've done that, then we're going to do the same with the lname. And if we go ahead and actually print these out, and of course, in order for the function to actually execute, we'll have to call the function. So I'm going to put two inputs in here. One, which is going to be just Angela all in lowercase. And then the second one is going to be Angela all in uppercase. And now when I run this code, you'll see that the result is they both get converted to title case. In essence, this part of the code becomes whatever the previous value of fname is converted to title case. You might have spotted already that this title function actually has an output. It returns a version of the string where each word is title cased. Instead of simply just printing this, we can also capture it inside a variable. Let's create a new variable called formatted fname and also formatted lname. Now, what's happening here is we are transforming this input fname, turning it into title case, and then once this function executes, it has an output. and that output replaces this part of the code, and then it gets stored inside this variable. Now we can go ahead and print the final version of our function, which is going to use an f string to take the formatted f name and then add a space and then print out the formatted L name, like this. Now, if I start out with my first name, but all in strange sort of casing, and then my last name in all caps, let's go ahead and hit run and see what happens. You can see that my first name gets converted to title case, my last name gets converted to title case, and then that result is stored in formatted F name, and this result becomes stored in this L name, and then they get printed and formatted, like so. Now, instead of printing this result out, we could also return it as well. In the same way that this title function returns the output, replaces this part of the code, we can also do the same with our format name function. So let's delete the print function and go ahead and use return instead. Now this formatted string becomes the output. And as we mentioned before, what happens with functions with outputs is this output replaces the part of the code where the function was called. Now, if this is the string that we want to print, then all we have to do is just to save the output, which replaces this part of the code, inside a variable like this. And then all we have to do is just go ahead and print that formatted string. As you can see, when I run the code, the same thing happens. Now you can, and you might have, alternatively, just taken this function call and put it straight inside the print statement. That works exactly the same way. And we can visualize this using Thonny. If I go ahead and paste everything we have inside the editor and go ahead and run debug, then we can step into and see what are the steps that happen. So the first thing when this line 6 gets executed is it tries to call this function, format name. So it passes in these two inputs, and we're now within the function where we have access to these two inputs, f name and L name. Now the formatted f name becomes the title case version of the first name, and the same thing happens with the last name. So we now have a formatted f name and a formatted L name, and that is what's going to be returned as the output. Now, once that's completed, that output replaces whatever was in between the print statement, which is where we called this format name function, and this is what gets printed into the console. As I mentioned before, we've actually already been using functions that we didn't create that have all of these functionalities, right? For example, the len function takes an input and has an output. The input is going to be a string, my name again. I seem to be really obsessed with my own name. So now this line of code is going to run this built-in length function, calculating the number of letters inside this input that we've given it, and then it's going to return the result as an output, which we can now capture inside a variable. This is the input, this is the function, and once this is completed, the return, or whatever it is after the return statement, is going to replace this part of the code. Then that result or output then gets stored inside this variable. So this return keyword is really the most important thing in order to create a function that has an output, because everything that comes after it is going to replace where the function was called. In the next lesson, we'll take a quick look at the return keyword in more detail. Specifically, let's see what happens when we have more than one return statement in the same function. All right, for all of that and more, I'll see you there. In the last lesson, we looked at functions that return some sort of value. We created a function called format name that returned a string. In this lesson, let's see what happens when a function has more than one return statement. When the computer encounters a line that has the word return on it, then it knows that this line is the end of the function. If I add a line of code after the return keyword, notice what happens when I run this code. It doesn't ever get executed. And this is because the return tells the computer that this is the end of the function and you should now exit the function. You can actually have multiple return keywords within the same function, and you can even have an empty return keyword, so just the return keyword without anything afterwards. So for example, we could check whether if the f name is equal to an empty string or the L name is equal to an empty string. So in this case, it means that when we called format name, maybe we didn't give it any inputs. For example, let's say that instead of just calling the function as it is, we actually used the inputs function. So what is your first name and what is your last name? Now what happens is it'll ask us for a input, and it will take these two inputs and then call that function and return the formatted version to be printed. So now in this case, it's possible that we might have just not given it a first name or not given it a last name, and it probably shouldn't go through these lines of code. But at the moment, it's still running this function, trying to get the title case from the empty string and then printing it. And I can prove this to you by just adding an extra word in here. So again, empty first name, empty last name, and then it prints result, and then of course nothing. How can we get it to bypass the rest of the code if the user typed in an empty first name or last name? Well, we could use what I mentioned before, an early return. So we could just write return without anything afterwards, and this is going to escape the function. So it's basically going to terminate the function early. Now, this time, if I leave an empty first name and last name, you'll see it prints none, because there is no output from this to print. Now, of course, it's probably safer to actually return something that tells the developer what's actually going on, so we can give a meaningful message like return something like this. So this way we can catch the cases when something is not quite right and then exit our function instead of wasting time for it to continue working on something that we don't want it to do. We've covered a number of things in today's lesson, and I want you to combine this with your existing knowledge to tackle the challenge in the next lesson, to get to grips with this concept of functions with inputs and with outputs. Head over to the Replit Day 10.1 Days in Month coding exercise. Here you'll notice that I've copied over the is leap year function that we created a while back in another coding exercise. Now, the first thing I want you to do is to modify this function so that instead of printing leap year or not leap year, we're actually just going to return true if it is a leap year and false if it is not a leap year, because we're going to be using that function in the next function that you're going to modify, which is a function that's going to tell you how many days there are in the month that you specify. So for example, if I was to call days in month and passing in the year as 2022 and the month as 2, then I should get an output of 28, as in there's 28 days in February 2022. This is the reason why we need to know about leap years, because in a leap year, there's actually 29 days in February. You're going to combine the output from this function as well as this list of days in the month in order to modify this function to output the number of days in a month when this line of code is called. It's really important that you don't change any of the code below, but you are going to modify this function and add more lines of code in it. Take a look at the hints if you get stuck, but otherwise pause the video and give it a go. All right, so the first thing I'm going to do is I'm going to change each of these print statements so that it returns a Boolean instead. So this one should return true and this one should return true. Now, when it's not a leap year, I'm going to return false instead. This way, basically, when we call this function isLeap passing in a year, then we'll get the output as either true or false. So we can now use that inside our function days in month. But before we do that, we need to get some inputs. We need to know what is the year and what is the month the user is interested in. So that is going to be passed in using these positional arguments. We're going to ask the user to input a year and input a month, and then each of these pieces of data gets passed into here and here, which will end up inside our function ready for use. The first thing I'm going to check is if the year is a leap year. How are we going to do that? Well, we're going to use our function here, isLeap, passing in that year, and then the output will be checked using the if statement. Remember that the way that if statements work is that if something is evaluated to true, then it's going to carry out the line of code below. But if it was evaluated and it turned out to be false, then it's going to skip this line of code. So instead of using true or false, or if 3 is bigger than 2, we're going to use the function isLeap and pass in the year that we got as an input. So this way, when a year is tested in this function, then it's going to output either true or false, which is going to replace this part of the code because it's the output from this function. So now if that output is true, namely it is a leap year, then we're going to check if the month they were interested in was the month of February. So if the isLeap year is true and the month is equal to 2, well, in that case, then we're going to return 29 because there's 29 days in February in a leap year. If this is the case, then this function is going to end right here when it returns 29. But if this is not the case, then it's going to bypass this line of code and we can output the number of days in a month for any other condition. So when it's not a leap year, we can go ahead and simply just use the return statement to tap into that list called month days. And we're going to pull out the value at the current month that's being requested. But remember that because lists start counting from 0 and the month that the user is going to be interested in doesn't start from 0. So if they're interested in January, then this month, instead of being 1, should actually be 0 to pull out this 31. So then we actually have to subtract 1 from it. So now if we test the code and we enter the year 2022 and the month of February, then we get the correct output, which is 28. That solves the challenge. Now, some of you I know might have gone even further because we talked about using the return statement to catch out any situations where there might be invalid inputs. So you could, if you wanted to, also add an if statement that checks whether if the month is greater than 12 or if the month is less than 1. In these cases, then it's actually an invalid input, and you could just return invalid month. And you could, of course, do the same thing for the year, and this way it ensures that our function doesn't progress unless we have clean data. But this, of course, is not necessary to complete the challenge, because we're now able to figure out the days in the month using this leap year function's output and the output from our days in month function. In the next lesson, I'm going to address something that a lot of students are thinking at this point. And the question is, why return at all? Why not just simply print the outputs instead? Because this way it seems to end up doing the same thing, right? It's still going to print this down here. And if we just added a print to this return and a print here and got rid of this one, then it would still behave exactly the same. This is exactly what I want to talk about in the next lessons. So see you there. Hey guys, I want to quickly spend a few minutes talking about a concept in Python known as docstrings. Docstrings are basically a way for us to create little bits of documentation as we're coding along in our functions or in our other blocks of code. Now, previously we've seen that when we use other functions, like the ones that were already defined by Python, like the length function, you can see that as soon as I open up my parentheses, I can see this little piece of documentation that tells me what this function is actually going to do, namely return the number of items in a container. So how can we create the same kind of documentation for the functions that we write? Well, we would do that using docstrings. The docstring has to go as the first line after the declaration. So here we've defined the name of our function, the inputs, and then after the colon, the first indented line will be the docstring. But that's not it. You also have to use 3 of these quotation marks, and it's in between these 3 quotation marks that you can write your documentation. We could write something like, well, what is this format name function going to do? What would we want our future selves or another user who's using this function to know about it? Well, it's going to take a first and last name and format it. Notice how with docstrings, you can actually write strings that are multi-line. Normally, if I was to create a normal string, let's say, I don't know, A equals a string. If I hit the enter key, I'm going to get a warning because it's going to interpret this as the end of this line. And it won't see this closing quotation mark as being a part of this string. But when we use a docstring, we can write as many lines as we want, and it will be interpreted all as the same thing altogether, as if it was fitted onto the same line like this. Now that we've added our docstring, it's time to see what it looks like. Now, if I call this function format name and I open up the parentheses, you can see that the text we wrote here now gets populated in the documentation. It takes the first and last name and formats it to return the title case version of the name. So this is a way for you to be able to start documenting your functions and giving each function a little bit of an explainer. Now, you can also use this as a multi-line comment. So notice how when we write a comment and we go to the next line, it becomes code again. Now, you can, in fact, use something like this, where you just comment as many lines as you like, and this will be interpreted as a comment as long as it's not assigned to anything. So for example, if I created a variable, then this is now a piece of code. Because it's a little bit confusing, the official Python guidance is actually to avoid multi-line comments like this. What is actually much easier is to just write your multi-line comment and then to highlight all of it, and then to hit Command and / or Control / on Windows. That's a much better way of differentiating the comment from actual pieces of code. Have a go at adding docstrings to the other functions that you've created and see it show up when you call your functions. So we're now ready to tackle our final project of the day, and that's building up a calculator program. If you head over to calculator-final.apri.repl.run, you'll see how the final project works. We get to enter a number and then pick an operation and then pick the next number, and it will calculate the result. Now, at this point, we can either continue to calculate with the result from the previous step, so let's multiply it by 2. Alternatively, I can type n, and that clears the screen and lets me start out a new calculation. Like so. Now, because a lot of the concepts that are covered in this project are actually quite difficult, I want to go through this project together. And while we're building it up, there's also a lot of small challenges along the way that I want you to tackle. Once you're ready, head over to the calculator starting file and fork your own copy to get started. This calculator is going to have some different functions that it can do. So for example, we'll start out with a add function, which takes two inputs, n1 and n2, and then it simply just returns n1 plus n2. This is pretty simple. This is all that there is to the functionality of adding. Takes one number and adds it to the other one. And I want you to go ahead to create the functions in this same format for these other mathematical operations. So subtract, multiply, and divide. Pause the video and complete this challenge. All right, so subtract is as simple as add. So we'll just call it subtract. We pass in again two numbers, n1 and n2, and we'll return the outcome as n1 minus n2. And for time's sake, I'm just going to copy and paste these for the last two, and I'm going to rename them multiply and divide, and then when numbers are multiplied, we use the asterisk sign, and when number are divided, we use the /. So now we have four functions: add, subtract, multiply, and divide. And what we want to do is we want to somehow store these functions inside a dictionary. Here's another challenge for you. Can you create a dictionary where the keys are each of these symbols that we've used to add or subtract or multiply, and the values are just the names of the functions? So pause the video and try that now. All right, let's go ahead and create this dictionary. Now we start out, of course, with a set of curly braces, and as I mentioned, each of the keys are going to be the symbols for the operations, and the values are going to be the names of the functions. So we've got plus, and then we've got subtract, multiply, and divide. So now we have this dictionary. Let's go ahead and save it inside a variable called operations. Now this dictionary is going to act as the means in which we're going to call these functions. At some point down here, we want to be able to tap into the operations and then pass in the key that we want. So for example, multiply, and then store this as the function that we want. That means we can then call this function and then pass in one number and a second number, and this function is currently going to act as the multiply function. Now if we change this to plus, then this function is now going to act as the add function. So now the next thing we're going to do is we're going to create a variable called num1, where we ask the user for an input to say, what's the first number? And this number, of course, has to be converted into an integer. Now, the next thing to do is to ask them for the second number. So this is going to be pretty much the same as this line of code, other than the word second. Now, the next thing is we want to ask them which of these operations they want to do. Firstly, we want to be able to loop through this dictionary and print out each of these keys. And then we're going to ask the user to type out one of them so that we can figure out which operation they actually want to do. Go ahead and try to use a for loop to loop through this dictionary of operations and print out each of these symbols. All right, now we're going to use a for loop, and we know that when we use a for loop with a dictionary, it will loop through all the keys rather than the values or the actual entries. We can say for each symbol in the dictionary operations, go ahead and print out the symbol. And at the moment, if I run this code, you'll see that it'll ask us for the first number, the second number, and then it's going to loop through that list and then print out all the operations. So now we're ready to go ahead and ask them for an operation symbol. Pick an operation from the line above. So they're going to see all of these keys, and then they get to pick an operation, like so. And that symbol is now going to be saved within this variable. So now we can go ahead and take that operation symbol to pick out the value that's associated with it. For example, if in this case the user chose the plus symbol, then we're going to pick out the add function. And then, just as I've shown you before, we want to use that add function to add these two numbers together. But of course, if they picked a different symbol, then we want to be able to carry out the different operation. See if you can get this calculator to work so we can print out the num1 and then the operation symbol and then num2 and finally the equal sign and then the answer. See if you can make this line of code work and make sure that it works whenever you choose any of these operations, and it'll calculate it using these numbers that you input. Pause the video now. All right, so the first thing we need to do is to get hold of the calculation function. And this is going to be done using the operation symbol. So we're going to tap into our dictionary of operations here, and then we're going to use the square brackets to pass in the operation symbol. Now we can use this calculation function as if it were any of these functions. And that's of course based on the choice the user made here. So we can now say calculation function, and we can pass in the num1 as the first input, num2 as the second input. And of course, our function all have a return value. And so this part is going to be replaced when the code runs with the actual answer. So we can now save that inside a variable called answer, and then that will get sent over here, and we can now test it out. So let's try adding 3 plus 5. So I'm going to use the add symbol, and we end up with 3 plus 5 equals 8. Now, what about something a little bit more complicated? 45, 78, and we'll choose multiply. Now, I think in reality, it actually makes more sense to put num2 after the user's entered the operation symbol, so that you actually end up with a better user experience like this. You can pick the first number, pick the operation, and then pick the second number. We've managed to get our calculator to work, but in this lesson, I want to talk about something else. I want to talk about the difference between printing something to the console over here versus returning something as an output from a function. Because a lot of students get very confused at this stage and they think, well, why don't I just print this result instead of returning it? What's the actual difference and why would I use return? That's what I want to address in this lesson. At the moment, we've got these 4 functions, and when we call it, we pass over some inputs, and then once we get hold of the output, we go ahead and print it out into the console. Now, in the current state of the calculator, it's hard to see the difference between the print and the return. But here's a question. What if we wanted to take the output that comes from calling this function, and instead of just storing it inside a variable and then printing it out, what if we wanted to pass it as an input to another function? Let's say that at this point, we decided, you know what, we're going to ask them to pick another operation. And then let's ask them to pick another number. And finally, let's go ahead and get the calculation function again based on this new operation symbol that they picked. And then we're going to calculate the new answer. But this time, instead of passing over the calculation function, we're going to pass over the answer that we got back from this step. So num1 is now the previous answer, and the second number that's going to be the input is going to be num3. At this point, when we're calling this calculation function, we're passing over the result or output of this calculation function, and that is going in right here, and then the third number goes in as the second input. What basically has happened here is I've taken the output from this function. So in fact, I could replace this answer with this output, And I've taken that as the first input into the calculation function, and then num3 as the second input, and then I'm using all of this in order to get the answer. Let's call this first answer, and let's call this second answer, just to differentiate the two answers. And now I'm going to write a slightly different print statement. In this case, the calculation is done using the first answer, and then the operation symbol, and then the num3 that was inserted at this point in order to obtain the second answer. So now if we give this a run, let's do just 3 plus 2. Now this first step of the calculation, we get 5 as the result. So now if I want to pick another operation, let's say I want to multiply 5 by 3, then I'm going to take this 5, which is the previous answer, I'm going to say multiply, and then I'm going to provide the next number, which we'll call 3, and now it takes the previous answer from the last step and puts that in as the first number in the calculation, multiplies it by 3, in order to get the final answer. In this case, what I'm able to do, because I have an output from my calculation functions up here, because each of these all return their answer, I'm able to take the result from that calculation and plug it right back into another calculation function using the result of that function call as the input to another function call. And I'm only able to do this because I'm using the return statement and because I have outputs from my functions. This would not be possible if I was using a print statement. In the next lesson, we're going to reorganize our code and introduce a while loop so that we can continue making as many calculations as we want to. In the last lesson, we made it possible to reuse the result of the first calculation. The answer for the first calculation became our input for the next calculation, allowing us to chain the calculations together. However, this created quite a bit of repetition in our code, and it limits our user to just 2 calculations. Let's allow our user to chain as many calculations as they want to. And I want to throw this over to you as a challenge. So can you use a while loop and the input function to achieve this? Ask the user this question. Type Y to continue calculating with the previous result, or type N to exit. If the user types Y, then your calculator should allow them to continue chaining together calculations with the previous answer. If they type anything else, the program should exit for now. I'll give you a few seconds to pause the video before I show you the result. Alright, so the easiest way to solve this is through the use of a while loop. So let's say that after we've asked for the first number and we've shown them all the different symbols that they could possibly pick from, let's set a flag called should continue. And we'll set that to start out as true. Then we can create a while loop, and while should continue as true, then we're going to perform these things. Now, we want to change some of this text so that it's a little bit more reusable. Let's say pick an operation and what's the next number instead of the second number. So now we have a first number, we have a operation, we have a second number, and then we pick out the function from that dictionary of operations and we get our answer. So I'm going to change this back to answer. And we're passing in num1 and num2 into the calculation function. Now, once this line has been printed, everything that occurs afterwards is pretty much repetition. And instead, we're going to ask the user to type Y to continue calculating with the answer from the previous step. Let's make that an F string and let's check what this is actually equal to. So remember that the input function is also a function that has an output, which is a little bit Zen, but the output of this function is whatever the user typed in. So if they typed in y, then this part is going to become y. That's where we're going to check. So we're going to check if the result of the input from the user is equal to y, then in that case, that means we should continue and it should repeat back. But when it loops back, we want to make sure that num1 is equal to the answer from the previous step. So we can say if this is true, then num1 is going to be set to equal the answer. But on the other hand, else, if they typed anything else, so we could say maybe type y to continue calculating with answer, or type n to exit. So now if they type y, then the answer is going to be set as the num1 back at the start of this while loop, so that this num1 becomes the answer from the previous step. But if they typed n, then we want this while loop to end. So we're going to change the flag should continue to false. So now let's give that a run. Let's say the first number is 5. Then we're going to add 3 to 5. And then we're going to type y to continue. So now we get to pick another operation. So let's multiply 8 by 2. And we get the result from the next step. And we can actually keep going until we're basically done, right? So we can take the 16 and we can divide it by 4. But if we type n, on the other hand, then our program ends and we see the prompt once more. And that's the solution to the challenge. But it's a little bit sad to just exit, right? Because with a calculator, more often than not, what you want to do is to start a fresh calculation where you get to determine the first number and the second number once more. If the user didn't want to exit, but if they wanted to start a new calculation, then how can we get them to go back all the way up here so that they provide the num1 as a fresh input? This is a little bit tricky, and in programming, this concept is known as recursion. It's basically the idea that you could have a function that calls itself. So let's define a new function called calculator. And this function takes no inputs and has no outputs. But all of this code that we've got here so far is inside the calculator function. To begin, when we start, we have to call the calculator function in order for it to find the place where this function was defined and to actually carry out all of these instructions. Now, the next thing we get to do is a little bit interesting, because when the user types no and says that they don't want to continue calculating with the previous answer, but instead they want to start a new calculation, what we want to do, instead of just exiting the while loop, we want to call the calculator function. Because what this is going to do is it's basically going to take us all the way back up to the beginning where we get to enter a new input again. And remember that once you reach the end of a function, everything gets reset to the beginning. So should continue becomes true again, and this while loop will continue working. So let's try running this new version. We performed a calculation, and now we want to start a new calculation. So I'm going to type n, and now I get to again define the first number again. This recursion basically happens because we're calling this calculator function within the calculator function. Essentially, the code runs and runs and runs until it reaches here. And if these conditions are met and this calculator function is called, then it goes and finds the calculator function in order to call it once more. But now you have to be quite careful with while loops and with these recursive functions, because let's say that instead of having all of this code and some checking code to determine when I should call calculator, if I actually just called calculator within calculator, then this is going to be an infinite loop. It's just going to keep going back and forth. The calculator function calls the calculator function, which goes back up and calls, and it goes around and round and round until forever. again, be careful and make sure that there is some sort of condition that needs to be met in order for this function to call itself. In the next lesson, we're going to add the finishing touches to our program and also fix a bug that you may have already spotted at this point. Now that we've pretty much completed all of the logic and functionality of this calculator, it's time to add in the bells and the whistles, including adding in the calculator logo and also checking for any bugs. Adding the calculator logo is pretty simple. You've done this loads of times before. All we have to do is import it from the art module, and then we're going to print it at the beginning of our calculator function. So this way, when we get to the end and the user wants to start a fresh calculation, we'll also show them a logo again. Now, the next thing to notice, this is a bit of a bug that you might have seen or not, but what happens if we try to enter a number with a decimal point? Let's say we want to calculate 4.5 multiplied by 2. Our program has already crashed as soon as I've entered 4.5 and hit enter. As a challenge, can you diagnose what went wrong and fix this bug? I'll give you a few seconds to pause the video before I give you the solution. Alright, here's the solution. The bug goes back to our lesson on data types. Notice how it's giving us an error and it's pointing to this line number 26. Line number 26 takes this input, which is a string, and converts it into an integer. But of course, a number with a decimal place shouldn't be converted into an integer. We should actually hold it as a floating point number instead. This way, we're able to perform more accurate calculations. So instead of just 4 times 5, we can do 4.5 times 5.5, for example. So instead of using int here, I'm going to change that to float, and I'm going to do the same here for num2. Now, when we hit run, I can actually perform calculations using numbers with decimal places, but I can also use numbers which are whole. So let's multiply 2.5 by 2. The answer is 5, and you can see that all the numbers are being reported to a greater level of accuracy, meaning they have numbers after the decimal point. And this is all because we converted that int to a float. Now, there's a lot more features that you could add to your calculator. You could add a square root capability, you could add exponent capability, but the important thing here was really for you to see how functions that provide outputs are really useful when you come to a more complex program, where you can take the output from one function call and pass it into the next function call as an input. So this output can be reused in different parts of the code. And this not only allows us to reduce repetition and also make our code more reusable and more modular, but also it gives us the flexibility of performing more actions after a function has completed. Now, we're going to be using a lot of the concepts that we've learned here today in tomorrow's capstone project. A lot of things I've explained, including things like the recursion, where we're calling a function within its own definition, or things like setting a flag using a while loop to continue some piece of code execution, is all going to come in really, really handy tomorrow. So make sure that if there's anything that you don't understand here, that you review it and you're comfortable with what the code is doing before you proceed. That's all for today, and I'll see you tomorrow. Hey, well done. You've completed day 10. That's a lot of progress. Now, tomorrow is a big day because there's the capstone project coming up, your very first one. And before that, you really need to get a good night's sleep so that your brain is refreshed and you're ready to go. So here are some of my tips for getting a good night's sleep. Firstly, don't set a wake alarm, set a sleep alarm as well. Have an alarm that tells you when it's time to start winding down, because we all know how easy it is to just keep watching YouTube video after YouTube video. I do that myself. Now,
Another really good idea is to avoid looking at a lot of screens about an hour or 2 hours before you go to sleep. The amount of blue light from the screens, even if you have night shift on, can make it really hard for your brain to start winding down and want to go to sleep. So one of the things I do is I actually have this, I don't even know what this is normally used for, but it provides a filter that gets rid of all blue light, and I sort of just walk around like this at night. So you can try this, or you can basically just read a book instead of looking silly like I am. And the important thing, but make sure that you get enough sleep and you get good quality sleep, and that you're prepared and ready to tackle the next day. So have a good night's sleep, good night from me, and I'll see you tomorrow.